If you happen to watch this on YouTube, the sound's not going to be quite as good because, yeah, the microphone, we used it in chapel today. We recorded Mr. Gaines preaching today. And so I left it on that recorder, and it's in my room. So it was great, yeah. Yeah, Mr. Gaines is pretty awesome. What's that? Never. That's not me. No, don't vote me on. I will reject the vote. All right, I will. All right. So no, I won't be speaking. All right, here we go. So this is called. All right, you had your time. So now it's my time. So this is called the quadrilateral angle sum theorem. Write that down. That's a mouthful. Quadrilateral angle sum theorem. Okay, so that's what this thing is called. So let's talk. You know what quadrilateral is. We've been talking about that last couple of days. You know what an angle is. You know what a theorem is. Let's talk about this word right here, the sum. If I talk about a sum in math anyway, what do we talk about? What are we saying? You're adding. That's exactly right. Okay, you learned that when you're a little kid too, right? When you add things together, that's the sum. So what are we going to add together? All the what? Angles of a quadrilateral. Very good. All right. So that's pretty easy. Actually, we're going to do more than just a quadrilateral. Yeah, we're going to do more than just a quadrilateral. We're going to go even a little bit further than just a quadrilateral. And you guys already said, before we even started recording, we said that the angles of a quadrilateral add up to be what? 360. Okay, 360 degrees. By the way, what else is 360 degrees? A circle. Exactly right. Okay, and we're going to show, I might show it on that GeoGebra program. We'll see if we have time to do that. Might do that at the end. All right, so the theorem, by the way, let's put the theorem back down there. So what the theorem says is, I'm not going to write it all out, but I'll read it to you. It's in the book. It says the sum of the interior angles. Now, interior, that means the inside angles, not talking the outside. We will talk about that later today. But the interior angles of a convex quadrilateral. Remember, a convex, like a quadrilateral would be something like this, okay? Because if I extended all the sides, they would go all outside. But what would be a concave? Concave would be like this. Everybody see that? All right, because then it would go inside. So we're not talking concave, we're just talking convex, okay? It says the sum of the angles, the sum, meaning all the angles, the interior angles of a convex quadrilateral is what? 360 degrees. Well, what we're going to do is we're going to show you why it's 360 degrees, all right? So let's do this. Let's start with a triangle. Let me come over here. I'll get me a polygon tool, click this. Oops. There we go. That's what I wanted. And I'm going to go 3 sides. There we go. So now I got me look at that. Got me a triangle. All right. So what we're going to do, let's get rid of this little thing. What we're going to do is draw a thing called a diagonal. Don't know if we've talked about that or not. Sometimes actually, I'm sorry. I lied. Yeah, we are going to use triangle, but not too much. So what if this was angle A, angle B, and angle C? So what do all 3 of those angles add up to be? On a triangle, what do they add up to be? 180, right? Yeah, that's something that we've seen a lot. That's something that we know. So we're going to use that. We're going to use this fact to be able to show you why the angles of a quadrilateral add up to 360 degrees. Is that all right? Okay, so with that said, let's go, let's change that back to white, and let's scooch that out of the way. And what I'm going to do is just draw some random 4-sided figure, which would be a quadrilateral. All right, so I don't know, we'll have it come out like this. Just don't want it to look like a regular like square or rectangle or anything. I don't know, let's say like that. I don't know, I'm just making this up. All right. Okay, so it's not really like a parallel. Well, I don't know. Kind of looks like a trapezoid, doesn't it? But let's just say it's any old quadrilateral. any four-sided figure. So what we're going to do, and I said this word earlier, and I meant for it to be right now. What we're going to do is we're going to draw a thing called a diagonal. Okay, this is something we're going to use quite a bit in this chapter. We're going to do a lot of stuff with diagonals. A diagonal basically means you start at any angle. It doesn't matter what angle you start at. I don't know, let's just start right here, okay? And if I draw a line from here to another angle, but I can't draw to the angle right next to it, okay? So the ones right next to it would be called the consecutive angles. We don't want to draw it to the consecutive. We want to draw it to a non-consecutive angle. Did you hear what I just said? So we're not going to draw from here to here or here to here. What's the only other place I can draw to get to another angle? Like straight across, right there. Everybody see that? So that's called a diagonal. Write that down. Diagonal. Again, basically it starts at one vertex and it goes to another vertex, but it can't go to the ones that are right next to it. That's it. I could have drawn another diagonal from here, couldn't I? All right, I could have, and that would just gone right here. All right, and that's really the only two diagonals I could have drawn in this situation. Agreed? But what I want to do is I just want to start from one point, just this point right here, and draw a diagonal. Now, doing that, that kind of shows why the angles of this quadrilateral add up to 360, because look at this. I made, how many triangles did I make? I made two triangles. I'll just call that triangle 1, and I'll call this triangle 2. Everybody got it? So how many degrees do all three of these angles right here add up to be of this first triangle? 180, right? So a triangle always has 180 degrees. Doesn't matter what the shape is, it's always 180 degrees. Well, I got a second triangle, don't I? So how many degrees is a second triangle? It's also 180. So that means, if I have two triangles, that means all the angles, okay? Now, they're not all equal. I'm putting one little arc. It doesn't mean they're equal to each other, though, okay? But all four of these angles must add up to what? 360. How'd you get 360? 180 plus 180. Exactly right, okay? So now, I want to make a little list. What we're going to do is we're going to do this about, I don't know, 3 or 4 times, okay, with different size shape. We're not going to do just quadrilaterals. We're going to do different size polygons or different the number of sides on the polygon. So if I have... We'll do this. The number of sides and the number of triangles. I'll just shorten that, triangles. Okay. So how many sides did I have on this polygon right here? I had 4 sides, didn't I? So how many triangles do I get when I have 4 sides? I get 2. Okay. Everybody with me on that? All right. So what we're going to do now, just to keep everything on here, I'm just going to erase this. Obviously, you don't erase this from your notes, but I can right here. All right, so I'm just going to get rid of that. And then I'm going to draw, should I just draw one or should I use this thing? I'll just do this. Now, this particular program draws them so that all the sides and angles are equal to each other. All right, but it doesn't have to be that way. Okay, it could be any. But how many sides do I have right now? I got 5. Okay, what do we call this? Remember we had a chapter a long, long time ago. It seems like we called a 5-sided figure a what? A pentagon, right? It's a pentagon. There's a pentagon. Where is there a big building that's called the Pentagon? What city? Washington, D.C., right? Okay, and if you look at it and you see an overview of it, it looks just like this. All right, it's called a regular pentagon because all the angles are equal to each other, all the sides are equal to each other. But this works whether or not all the angles are equal or all the sides are equal. It doesn't make any difference, okay? I'll tell you what, let's stay with our color scheme. So let's turn this back to white, and we'll use our diagonals as yellow, all right? Make that yellow. All right, so now pick a vertex. It doesn't matter which one. Let's just pick this one over here off to the left. It doesn't make any difference. So what I want to do is I want to draw all the diagonals from that one vertex. Can I draw it to here? No, I can't draw to the ones next to it. I got to draw to the ones across from it. So I draw one here. Now, are there any other ones I could draw from that one particular point? Yeah, there's another one. I could draw it down here, couldn't I? Everybody see that? Okay. So now, again, we're coming up with a little theorem of our own. Okay, we're coming up with a formula on our own with a little help from me. All right, with a formula, and we're going to see we're gonna see a oh my gosh, I said the word earlier. We're gonna see when it repeats and you oh my gosh, I can't believe it. That's what happens when you get old like me. What is that word? I want to see. It happens a few times. You're like, oh yeah, that a pattern. I want to see a pattern. Okay, I can't believe I forgot that word. I want to see a pattern developing. So if I have 4 sides, I'm going to have 2 triangles. Everybody with me? So now take a look at this. You should see it right now. How many? I got 5 sides now, don't I? So how many triangles am I going to have? I'm going to have 3. There's 1. There's 2. There's 3. So I have 3 triangles. Agreed? Let's do one more to kind of establish a pattern here. Yes.
I swear I do it like
all right, go. Just go. You don't explain it to me. Just go. All right. So now you should be kind of guessing what our next one's going to be. Let's make that 6 sides. There's 6 sides. Again, it doesn't have to be all equal sides and all equal angles. Now let's turn that back to white so we can get our color scheme going here. All right. Now, let's start with any vertex. Again, it doesn't matter what vertex you start at. It doesn't make any difference. I don't know. I just like to go from here because I like to go left to right. Okay, so let's start from this vertex right here. Let's see how many diagonals I get here and how many triangles I'm going to get. So I start here and I go to this vertex. All right. And then start at the same starting spot, go to another one. So that's another diagonal. And then I'm going to go to the starting point, go to this one. Are there any other diagonals I can draw from that point? No, because if I draw here, that's a consecutive side. I can't do that. Same thing with that. So let's take a look. Let's count them up. How many triangles am I going to get? 1, 2, 3, 4. So how many sides did I have? 6. How many triangles do I have? 4. Do you start seeing a pattern now? Let's do one more. Okay, I think one more. I think you can see the pattern right now, right? But just for fun, let's see what the pattern is. How did we get from 4 to 2? How did we get from 5 to 3? How did we get from 6 to 4? That's the pattern. And there is one. Okay? Hopefully you see it. Let's do one more. And let's go back to this polygon. And let's make this 7 sides. Is that all right? We'll just go in order. So let's make that 7. There you go. There's 7 sides. And let's do the whole... Yeah, you don't really see a 7-side figure too much, do you? But there it is. Yeah, we call it a heptagon. I had one book. I don't know. Do you remember the story about the other book I used to use? They didn't call it a heptagon. They actually called it a 7-gon. It's kind of weird. They had words for everything else, right? They had hexagon, and then they had octagon, and in the middle they had 7-gon. But we call it heptagon. Start at any vertex. It doesn't matter. Let's just start right here. Let's draw the diagonals. So I'm going to go from here to here. And I'm going to go from here to here. That's another one. And then from that starting point to this other vertex. I mean, I could do this all day, couldn't I? With more and more sides. But I just want to establish a pattern. Let's count them up. You should probably have guessed how many triangles we're going to get. Did you already guess? Yeah. All right, this is the last one we'll do, though. So there's 1, there's 2, there's 3, there's 4, and there's 5. So there's 5 triangles. So if you have 7 sides, guess how many triangles you're going to have? 5 triangles. Let's jump ahead without drawing the picture. What if you had 10 sides? How many triangles are you going to get? 8. What if you had 100 sides? How many triangles are you going to get? You're going to get 98. No. Oh, I could. With this program, I can do it. Okay, I will. What are we doing? 100? Oops. Why does it do that? Click. There we go. All right, 100. All right, watch this craziness. Ooh. Now, you're like, wait a minute. What's up with that? That doesn't look like a triangle, or that doesn't look like sides.
Increase the size so you can see how big it is.
I'm going to. But I need to make it a little smaller because when I make the size big, it's going to go right to the middle, and then I'm going to have to scooch it over like a really... Okay, so anyway, so let's take a look.
Whoa!
Now, it's even still to... I'll tell you what I can... see if I... Oh, I know what I can do. I hit that.
Whoa.
See, and it's still, even though there's 100 sides, yeah, you start seeing a little bit of a corner right here, okay? And I think that's as big as it goes. I don't. It doesn't go any bigger than that. But you see a little bit of a corner right here, don't you? Everybody see it? Okay. So listen. So that angle is really, really, really close to how many degrees? It's about 180 degrees. Just a little bit smaller than 180 degrees, isn't it? Because if it was straight, it would be 180. But it's just a little bit tilted. All right. See, that's why I made that real small like that. So what's cool about it, remember I asked you earlier about what else has 360 degrees? What'd you say? A circle. So you could see the more and more and more sides I get, what does this polygon start to look like? It starts to look like a circle, okay? Which has how many degrees? 360 degrees. Isn't that crazy? But how many degrees did that 100-sided thing have? Well, let's do that. Let's do some math here, all right? So if these have two triangles, how did we find out what all the degrees added up to be? I took two triangles. Each triangle has how many degrees? 180. So if I have two triangles, I got what? 2 times 180 degrees, which is what? 360. Who's got a calculator handy? Okay, get it out real quick because when we get to some of these bigger numbers, I forget what they are. All right, so a 4-sided figure. Everybody's watching, right?
I got this, Mr. Hammer.
Sounds like some of you guys have lost me already. Let's put it right there. Here we go. So if I have two triangles, right? 2 times 180 is 360. So when I have 4 sides, that means all the angles added up. The sum, listen to what I'm saying. The sum of the interior angles equals 360 degrees. Agreed? All right. Let's do the next one. So this would be 3 times 180. What's that? 540. So if I took a pentagon, right, 5 sides, and I added up all 5 angles, if I added them all up, guess what I'm going to get? 540. Now I'm going to ask you another question after I do these. I want you to think about what each of the angles is going to be if all the angles were the same. You hear what I just said? So I want you to think about that. We'll get to it after we do all this. All right? So that's 3 triangles. 3 times I probably should have put this right next to where the triangles are, but that's okay. So what's the next one? 4 times 180. What's that? 720. Okay, if I had 5 times 180, 900. I should put the little degree symbol there, shouldn't I? Okay, let's jump up a little bit. Remember, we jumped a little bit. So what if you had 10 sides? What's the name of a 10-sided polygon, by the way? It's a decagon. So what if I have, watch this. What if I have 8 triangles? Actually, let's do this. I skipped one that I think is important to do. We skipped 8, didn't we? 8 is a what? 8's an octagon. So how many triangles? 6. So let's do that one. 6 times 180. What's 6 times 180? Yeah, 1080, right? After you do these for a while, you start recognizing it. Okay? I don't always. But anyway, let's do the next one. So if you had 10 sides, you have 8 triangles. What's 8 times 180? 1800? Okay? Now, let's do this. Now, look. All the angles add up to 1800 degrees. Okay, that's what we're saying. I need you guys to listen. What if you had 100 sides?
Thank you.
Now, I have no idea what this is. What's 98 times 180?
1 million. No.
17640. Is that right? So 17,640 degrees on a 100-sided polygon. Okay? Now, let me ask you this. It was a question I asked just a minute ago. Okay, what if all of these were... Well, let's change it to something reasonable. I'll tell you what, let's change it to 8. Because you see this every day. Where do you see this every day? Yeah, it's a stop sign. Okay? It's in... You guys are taking driver's ed now, right? 10th grade? Okay, so let's look. What I want to know, does it occur to you that you shouldn't be talking? Does that ever occur to you? I just don't understand, because just like 2 minutes ago, I asked you to be quiet and not talk, and now you're doing it again. But just don't talk. I would rather you not talk than apologize, okay? It's an empty apology if you keep talking all the time. So let's just listen to me. So look what we have. We've got an octagon. It's something you see every day. It's a stop sign, okay? What if I asked you to find out what just one of the angles are? Now, on a stop sign, all the sides are equal and all the what are equal? All the angles. So every single one of these angles are exactly the same on a stop sign. All right, Trent, tell me.
Would you divide by the number of sides?
Yes, exactly right. So this is an octagon, right? So I did it right here. This is the octagon right here. Everybody see that one?
Yes.
So all the angles, all 8 angles, add up to 1,080. Okay, that's what all the angles. If I took this one plus this one plus this one all the way around, that would be 1,080. But I want to know what each of those angles are. So Trent said I divide it by how many sides. Because if I have 8 sides, how many angles am I going to have? I'm going to have 8 angles. Count them up. 1, 2, 3, 4, 5, 6, 7, 8. Yep. I got 8 sides, 8 angles. Okay? So I divide by 8. Everybody understand why I would divide by 8?
Yes.
Okay? Now remember, I multiplied by 6 to get 1080. Why did I multiply by 6? Because you always take 2 less, right?
Right.
All right. So if I divide that, who's my calculator guy? Should be 135, if I'm right. I just been doing this so much. Is it 135? Come on, what's taking you so long?
It's 135.
Thank you. 1080 divided by 8 is 135. So each angle. It's not time to pack up. You got 7 minutes left. So watch. On a stop sign, each angle is 135 degrees. You could do that with any polygon. So let's come up with a little formula, all right? So if you have the number of sides, we'll use the letter N to represent the number of sides. We'll do this, number of sides. Okay? So let's come up with a little formula on how to figure out, let's just do the sum. Let's not worry about each one just yet. What about the sum of the angles? The sum of the angles of any convex polygon, all right? So what is our little formula? What do? We take the number of sides. So what did we do? We took how many sides we had, 8 sides. How did we get the 6 out of it? We subtracted 2, didn't we? All right, so if n, listen, if n represents the number of sides that we're talking about, what do I do to that n? I subtract a 2 from it. Then, once we subtracted a 2 from it, what did we do to it? That's how many triangles we get. What did we do to this? We multiplied by 180 degrees. So this right here is our little formula that we kind of came up with on our own, didn't we? Was paying attention? So this is our formula for the sum of the angles of the interior of any polygon. This works for any polygon. So if I had 57 sides, if I asked you to find the sum of the angles of a polygon with 57 sides, what would you do? Well, you take the sides, and what do you do to the number of sides? Subtract 2 from it. And then, after you do that, then what do you do to that number? Multiply it by 180 degrees. Put it in a calculator. Okay, I don't know what that is. You got your calculator? So what is it? 55, right? Times 180, which would be what? 9,900? Like that? Okay. So that's how many degrees. It's absolutely going to be on a quiz and a test.
Yes.
Okay? I'll give you the sum of the angles. Now, I'll also ask you this. I'm also going to ask you, find each of the angles if it's a regular polygon. What do I mean by a regular polygon? All the angles are equal and what? All the sides are equal. Okay? So if you had this only works when that's true. Okay? You can only find each angle if all the angles are exactly the same. Okay? So how would you do that to this? How to find each angle? Yeah, you take the sum, the 9,900, and divide it by, how many sides did you have on this one? 57. I just picked some random odd number. All right, calculator. 9,900 divided by 57. What's that? It's probably some weird answer. 57. It's right there. 173 point what? 6 what? 6'8"? So let's say 7. Okay? Degrees. It'd be approximately. All right? So that's what each angle would be if you had a figure that had 57 sides to it. And if it was a regular polygon. Everybody got that? Here's one more thing, and then we'll finish. This is kind of interesting, I think, anyway. Let's do this polygon thing, and I'm not going to make it 8. Let's make it 5. Okay? Whoops. All right, so let's make 5-sided. So we got a pentagon. Come on. There we go. Now watch this. This is really, I think, pretty cool. If I did this, let's do some blue this time. It'll be different. If I took this and extended that side, I took this side and extended it that way. If I took this one, extended it, this one. Do you see what I'm doing? Just taking that side, just stretching it out. You're watching, right? Okay. Now watch. We just talked about all the interior angles, didn't we? But now, this is a special theorem, and it's actually a little easier. It's a special theorem that talks about all the exterior angles. So let's see the exterior angles. Everybody watch. See this angle right here? That's an exterior angle. This one right here is an exterior angle. So is this one. So is this one. So is this one. Now, this is really, it blows my mind. All right? All the exterior angles, no matter how big the polygon is, always adds up to the same exact number. It doesn't matter if it's a triangle. It doesn't matter if you have 5 sides, 10 sides, 100 sides, 1,000 sides. All the exterior angles add up to be the exact same number. And what is that number? The sum of the exterior angles of a polygon. Add up. Watch. Don't leave me. We're about to do this. Sit down. Bell doesn't dismiss you. Sit down. I'm not going to let you go until you sit down. Thank you. The sum of the exterior angles equals 360 degrees. It does not matter. It does not matter how big the polygon is. The exterior angles will always be 360 degrees. So now you got enough information to do your homework. And it's what, 1 to 18? All right, so it's section 6-1, 1 to 18. There it is.